Hello. Please hit like button and subscribe my channel. Also press bell icon for future video notifications. Thanks.
In giant clusters of hundreds or thousands of galaxies, innumerable stars wander among the galaxies like lost souls, emitting a ghostly haze of light. These stars are not gravitationally tied to any one galaxy in a cluster. The nagging question for astronomers has been, how did the stars get so scattered throughout the cluster in the first place? Several competing theories include the possibility that the stars were stripped out of a cluster's galaxies, or they were tossed around after mergers of galaxies, or they were present early in a cluster's formative years many billions of years ago. A recent infrared survey from NASA's Hubble Space Telescope, which looked for this so-called intracluster light, sheds new light on the mystery. The new Hubble observations suggest that these stars have been wandering around for billions of years, and are not a product of more recent dynamical activity inside a galaxy cluster that would strip them out of normal galaxies. The survey included 10 galaxy clusters as far away as nearly 10 billion light-years. These measurements must be made from space because the faint intracluster light is 10,000 times dimmer than the night sky as seen from the ground. The survey reveals that the fraction of the intracluster light relative to the total light in the cluster remains constant, looking over billions of years back into time. This means that these stars were already homeless in the early stages of the cluster's formation, said James G. of Yonsei University in Seoul, South Korea. His results are being published in the January 5 issue of Nature magazine. Stars can be scattered outside of their galactic birthplace when a galaxy moves through gaseous material in the space between galaxies, as it orbits the center of the cluster. In the process, drag pushes gas and dust out of the galaxy. However, based on the new Hubble survey, G rules out this mechanism as the primary cause for the intracluster star production. That's because the intracluster light fraction would increase over time to the present if stripping is the main player. But that is not the case in the new Hubble data, which show a constant fraction over billions of years. We don't exactly know what made them homeless. Current theories cannot explain our results, but somehow they were produced in large quantities in the early universe, said G. In their early formative years, galaxies might have been pretty small and they bled stars pretty easily because of a weaker gravitational grasp. If we figure out the origin of intracluster stars, it will help us understand the assembly history of an entire galaxy cluster, and they can serve as verses. Dark matter is the invisible scaffolding of the universe, which holds galaxies, and clusters of galaxies, together. If the wandering stars were produced through a comparatively recent pinball game among galaxies, they would not have enough time to scatter throughout the entire gravitational field of the cluster and therefore would not trace the distribution of the cluster's dark matter. But if the stars were born in the cluster's early years, they will have fully dispersed throughout the cluster. This would allow astronomers to use the wayward stars to map out the dark matter distribution across the cluster. This technique is new and complementary to the traditional method of dark matter mapping by measuring how the entire cluster warps light from background objects due to a phenomenon called gravitational lensing. Intracluster light was first detected in the Coma cluster of galaxies in 1951 by Fritz Zwicky, who reported that one of his most interesting discoveries was observing luminous, faint intergalactic matter in the cluster. Because the Coma cluster, containing at least 1,000 galaxies, is one of the nearest clusters to Earth, 330 million light-years, Zwicky was able to detect the ghost light even with a modest 18-inch telescope. NASA's James Webb Space Telescope's near-infrared capability and sensitivity will greatly extend the search for intracluster stars deeper into the universe, and therefore should help solve the mystery. Hyungjin Ju, M. James G. Intracluster light is already abundant at redshift beyond unity. Nature, 2023. 613, 7942, 37 doi, 10. 1038, S41586, 022, 05396, 4 NASA, Goddard Space Flight Center. Hubble finds that ghost light among galaxies stretches far back in time. Science Daily. Science Daily, 4 January 2023. ift.tt/W5H0KPL. NASA, Goddard Space Flight Center. 2023, January 4. Hubble finds that ghost light among galaxies stretches far back in time. Science Daily. Retrieved January 4, 2023 from ift.tt/W5H0KPL. NASA, Goddard Space Flight Center. Hubble finds that ghost light among galaxies stretches far back in time. Science Daily. ift.tt/W5H0KPL. Accessed January 4, 2023. Thanks for watching. Please subscribe my channel for more videos.